Hope you're not too hot. So let's talk a bit about decentralized cloud, not only specific about AI, but more generalized. And let's look into the Moore's Law. And so Moore's Law has been around since the 60s, essentially outlining that with every 2 years, the development in microchips will double, while the price will be halved. But this has been true until recently. Nowadays, we have a lot of limitation when it comes to kind of the physical size. So we cannot further shrink, essentially, the microchips anymore, or with a lot of effort, essentially. And energy efficiency has become more and more important, which means that we are essentially ending up in kind of a new Moore's Law, where we're saying, hey, the performance per watt, so the compute power, is essentially more important. Now, let's keep this in our heads while also looking essentially at why this is, right? So nowadays, the compute performance is really kind of focusing on the energy prices, because we are living in a time where energy essentially becomes more and more valuable. So this is translating directly as well into operating costs, for example, of like a data center. And on the other side, we're also all aware of global warming, obviously. So the kind of ecological aspect of it, so the sustainability aspect, is becoming more and more important also for bigger companies in the end, when they're looking at ways for offering compute. Now, an interesting fact is that 66% of the global cloud market is controlled by only a few companies. And they're also US companies. So when we're looking at that, kind of thinking about what can we do with kind of decentralizing the cloud, how can we essentially approach it? What are the kind of downsides of the existing cloud nowadays? And on one hand, you have a lot of lock-in when you're working with the existing cloud, which means that essentially for a lot of times, and we have experienced this as well ourselves, is you deploy an application, it might be quite effortless, but in the end, you don't really are aware of the pricing situation. So what we've had experienced with as well is that we ran a service, then suddenly, overnight, we got charged like 10 times the amount. And this is something that is not only happening to us, but also to others. We have a lot of people reaching out and saying, hey, look, this is kind of the experience that we have had. And then on the other hand, when you're working with a centralized provider, obviously, the data ownership is not always quite clear. If you're working with a US-based company, then it's not only a matter of fact that through the Patriot Act, kind of the US government could take a look at the data in the end. And that's also something that probably is not very cool for everything, right? And then the kind of access barrier as well is another aspect of this. Now, keeping in mind kind of the developments in the Moore's Law, kind of this performance per watt, and what the current cloud currently stands for, what can we do to essentially change this? And what we are saying is we cannot play by the same rules. We cannot create a decentralized cloud with servers that are being set up nowadays, because still the centralized providers, they have the economy of scale, right? They can set up big server centers, get a lower price on all of the server hardware. So what we are saying is, look, we are not building this decentralized cloud with servers, but we're leveraging mobile hardware. And a lot of people maybe hear a bit less in the DePIN space, where a lot of mobile projects are around and about, and really understand kind of the advantages that a mobile phone can bring. But a lot of people don't really understand the massive untapped opportunity that the device that we're carrying in our pocket provides, because they're fully packed with huge CPUs, with a lot of RAM, with GPUs, even hardware accelerators like the TensorFlow processing unit, which can be utilized for AI. Now, still, when we talk about this to people, it's usually like, okay, good, you can do this with a mobile phone, but then you need 100 for essentially replacing one server, right? But that's actually not the case. It's really interesting to take a look at certain examples, like we have here. You have a Dell server rack that costs like $3,000. You can compare the compute power on the CPU level with a Google Pixel 7a. And there you already have like a 6x difference in acquisition cost. And then, thinking back to the Moore's law, the mobile phone itself uses way less energy. So the running cost of this is is brought down by a huge factor as well. So besides that, now thinking about, okay, 6x lower acquisition cost, lower running costs, what we can also utilize is the fact that there are so many smartphones being upgraded each year, and the old device often kind of ends up lying somewhere in a drawer. And there are also devices that have, for example, a broken screen, which don't really have much resale value in the end. So we can leverage this fact by saying, hey, you can essentially buy this one device that would cost $500, that has the same compute power like a $3,000 server. You can buy it for $25. And then it's still valid for compute. You can onboard this device, utilize the same compute power, and essentially, there you go. You have a way lower acquisition cost and way lower energy cost in the end. Now, this is one side of the picture. So you have essentially the providers of the cloud, right? The compute that is being provided, but someone needs to use it as well. And why would they use it? It's essentially they are getting way affordable compute because we can transfer all of the savings that we have made on energy cost, acquisition, and everything else directly over to the developer. And it's also performing better than existing like AWS Lambdas, for example, or Google Cloud Functions. Now you might think, okay, these are some made-up stats, but it's actually research that our head of research has done with the University of Zurich in the IEEE workshop that is being hosted by DePIN, by IoTeX. So this is something that is based on facts as well. Then let's quickly look ahead what is out there for Acurast. So right now, you can already deploy JavaScript and Node.js applications. You will be able to deploy Python VM, PyTorch, and TensorFlow applications to this environment. Outside of that, currently, we support about 500 different Android devices to be onboarded as providing compute. This will be extended shortly to iOS devices, as well as you can use the one that you carry around in your pocket, because initially these are dedicated devices, and this will change. Now, last but not least, we are already live with our incentivized testnet, and we are about to launch our points program. So now is a very good time to essentially look into your drawer, see if there is a device, and onboard like one of the thousands of devices here that we have. Now is your chance, and take a look if you want to become a processor on Android and provide compute. Thanks, everyone.